Hey guys, welcome to Piece of Code and welcome to this video. So in this video series we are going to see a lot of common AWS solutions architectures which come in the exam a lot, right? And yeah, a lot of people also requested for it and it's very interesting and I'm very excited to do this video. And this architectures that we are going to learn, it is not just common to AWS guys, because you can take this high level architectures and you can apply it to any cloud service provider like Azure, GCP, or even on-prem as well, because this is the way in which you arrange your arrange your services and put it in a pattern, put it in an architecture. And AWS is just a service provider. It is up to you how you use them together, right? So you can take this and it can be like a combined preparation for you guys. You can also use this for preparing for other cloud service exams as well, like Azure or GCP or whatever, right? Okay, let's start the video guys. And the first set of architectures that we're going to see is the caching strategies guys, because I have seen a lot that in the exams these caching strategies come a lot, right? Even though people know about the caching services like Elastic Cache, or if you want to cache in database, then read replicas in case of RDS and DAX clusters in case of DynamoDB. Even though people know about that, they still have problems while integrating it with other services. That is very, very important. You need to know how you can use the services with other services in AWS. That's how these architectures are formed. Okay, so let's see this use case guys, the first use case, and it says on-demand cache to reduce real-time calls. Now as the name suggests guys, this caching is all about on-demand caching or lazy loading, and this uses a cache aside design pattern approach. Remember this thing guys, whenever you are talking about lazy loading of cache or on-demand cache, we generally use a cache aside design pattern. Now let's take this example that you have over here. Below we have a diagram over here, and try to understand how this caching strategy actually works. So we have our API gateway over here, and we have three microservices over here: billing microservice, payment microservice, and profile microservice. Each have their own separate functionalities and whatever. We have a cache manager which is used to manage the cache, read write operations on the cache and everything, and we have our data source over here, and we have our EventBridge which will trigger events in case someone publishes them. We will see that later, don't worry about it. Let's talk about a simple request coming to the Amazon API gateway. For example, this some client requested for some billing data of a user, for example /user/billing and /user ID, which is 101. Now this API gateway will take that request, and if you have some mapping over there, it will obviously redirect the request to the billing microservice. This billing microservice, what it will do, it will first check in the cache with the object key, right? If it is available or not in the cache. If it is available, well and good, it will return the data back to the billing microservice, and this billing microservice will return the data back to the client through the API gateway. That is fine. But what if the data is not present in the cache guys? In that case, the billing microservice will call the data source, like the database. It will get the data, then it will update the data in the cache, and then it will return the data back to the client. Now if again the third time someone requests for the same data, then what will happen? That data will still be present in the cache, because after getting the data the first time we updated the cache. So next time when we fetch the same data, it will be in the cache. The cache will return the data back, and the billing microservice will return back the data to the client through the API gateway. Pretty simple guys, right? So that's how lazy loading works, or on-demand loading of cache works. Now let's take an example over here. let's say this user ID belongs to a person named Ron, right? User is Ron. Now Ron, what he wants, his balance, his current account balance is 500 rupees. Now Ron withdraws some amount from the balance, so it is 500 minus 200 rupees he withdrawn from his account. Now the current balance is 300 rupees. Now the current data in the cache is still 500 because that is still not updated in the cache. Now how do we update that? So obviously any withdraw request will come to the payment microservice, right? Payment microservice. So the payment microservice, it will update the balance in the data source. Then what it will do is this payment microservice will publish one event to the EventBridge. Now if you guys know about EventBridge even a little bit, you will be able to understand this architecture. Using EventBridge we can invoke a lot many AWS services, right? Based on the event we have a bus, EventBridge bus, and using that bus we'll be able to invoke a lot of AWS services. Now in this case, we, for example, the event that we receive in the EventBridge is withdraw event. So the EventBridge will understand, okay, this is a withdraw event. It will take that event and it will invoke, it will trigger the cache manager microservice over here. That's also a Lambda function. Now this cache manager microservice, what it will do, whatever the balance is, the current balance is 300, it will take that and it will update it in the cache. Now the updated balance is 300 in the cache. So the next time when someone requests for some data to the billing microservice, for example, it will get the updated value of 300 rupees from the cache, right? That makes sense. Amazing thing, right? Now in this example you saw how we integrated Amazon API Gateway, Lambda, EventBridge, and also some kind of database. And this is how lazy loading or on-demand cache works. Pretty simple, right? If you have any doubts, please ask in the comment section, guys. So let's move on to the next caching scenario, which is proactive caching of massive volumes of data. So sometimes what happens is that, for example, you are running an app for 50 years, for example, 50 years, and it is on legacy infrastructure. Now you are moving to the cloud. That cloud moving is known as a migration process or a data migration process. There are a lot of strategies of data migration. If you are interested in those strategies, please refer to my disaster recovery and migration video that I have on my playlist. So during this migration, a lot of updates happen and you may have some downtime, right? So in that case, what you will do, you will load all the initial data into a cache. In this case, the cache and the database that we are using is DynamoDB and DAX cluster, right? You initially load all the data into your particular cache, and what will happen if some request is coming to the microservice, instead of querying the database, it will query your cache. And as all the data is already present in the cache, that shouldn't be a problem that there is some missing data, right? So what will happen? Some request comes in. It's same as the first use case that we saw. Some request came into the billing microservice. This will query the cache, and the data should already be present there, and it will return the data back to the client through the API gateway. Now there might be some scenarios, obviously something may happen. This is engineering, anything can happen, right? There might be some scenario where you do not have the updated data, or some data changed in the data source. That is an absolutely valid use case. So if that happens, you can have a periodic CDC. CDC stands for change data capture. You can have a CDC pipeline. So whenever some data is changed in your data source over here, you can push the data through the pipeline to your data cache, and whatever updated data that you have, it can be replicated to your cache. Now you can ask me another question. What if some data changes from the client side? For example, the same scenario, right, that we have a user Ron, right, he withdraws some data from the, using the payments microservice, and we need to get the updated balance from the data source, right? In that case, the similar kind of thing you can do, that you can have a event bridge over here. So if there is a withdraw event happening, it will publish the event to your event bridge, and the event bridge will invoke your cache manager Lambda function, and your cache manager Lambda function in turn will update the cache over here. That makes sense, right? I hope that is making sense. So you see over here, that difference between the first use case and second use case is that we have different scenarios where we use both of these use cases. Now, one small hint I will give you guys, and it's a very good hint, that whenever in the exam you are asked a question that you have to implement a cache, it must be efficient and it must be cost effective. In that case, guys, there's a 110% chance that you have to go with a lazy loading solution. In the exam, if the cost is not a matter and you need to do migration, or there is some heavy lifting of work done, and the users need to use the query the data in that scenario, you will go with the second scenario, which is just pushing all the initial data at once, or massive volumes of data. You just preload the data all at once, in simple terms. Now some things in the end that I want to discuss. The data in DynamoDB can be loaded through different methods. That is a different concept. Like whatever migration strategy you want to use, you can use it. DynamoDB supports a lot of strategies, and whatever the functionality of API Gateway, Lambda and EventBridge, those are the same. They will not behave differently in different caching strategies, guys. Use case 2 is also beneficial in scenarios where the applications must cache data for an extended period of time, such as a customer shopping cart. That is also a very valid scenario where the use case 2 can be implemented, guys. Okay, so that was about the caching strategies. Let us move on some more architectures, guys. Okay guys, so let us talk about architectures related to this API Gateway, Lambda, Kinesis and SQS. Very interesting and very important topic in terms of architecture as well as the exam perspective, right? If you are giving solutions architect exam or professional level exam, these kind of questions, they come like in every exam, right? So how can we combine all of these strategies or services and make an architecture out of it, make a high level architecture out of it, right? Let's consider this first scenario over here, right? Scenario number 1. So you have some streaming data, right? And a very quick, I would say suggestion when it comes to streaming data, right? The first thing that you should come into your mind should be Kinesis data streams. So anywhere in your architecture, Kinesis data streams should be there, because it provides you real-time streaming data, right? I mean, you can process the streaming data in real time, right? So that should be part of your architecture, fine. But how can you add more things into your architecture to make it more interesting and performance-wise and also cost-wise? For example, let's say the streaming data you are capturing through an API gateway. You have an API, right? Which to which the streaming data will come or hit your API, right? So we use the API gateway for that, right? Pretty simple. Whenever you talk about APIs, API gateway should come into your mind, right? Now we have a Amazon Cognito service attached to it. Why? Because, for example, you want to check the identity from where the particular request is coming, because in Amazon Cognito you have two things, right? One is user pools and another thing is identity pools, right? So to actually see that the user is authorized to get the particular service or not, you use Amazon Cognito for that, right? So it's pretty simple, and I've explained this user pools and identity pools in my Amazon Cognito video, so you can have a look at it if you want to get more in-depth knowledge on it. But just from the architecture perspective, you should know these things, that Amazon Cognito is used for this authorization and authentication purposes of users or external users. That is fine. Now the third step, you see, we direct that data to Amazon Kinesis data streams. As I told you, the data stream should be part of your architecture if you have some streaming data, right? Now this data streams can have multiple locations, right? Multiple endpoints, like wherever you can send the data, not endpoints, like the destinations, right? And in this case, the destination is a Amazon Lambda function, for example, right, which will in turn take the data and do some manipulation on it, or maybe store it in some database, for example in DynamoDB or it can also visualize the data, right, send it for visualization purposes. So you can extend this pipeline to wherever you want. It's the I would say the things are countless. You can add multiple things and make your architecture much more what we say, better. So from here you can the Lambda function can manipulate the data and do some thing on it and then send it to a different place. And you can also attach a SQS queue for failed records, so that, for example, it can be a DL queue also, dead letter queue also. I have explained DL queue in detail in my SQS video. You can go and have a look at it. So you can keep it in a SQS queue and you can reprocess the data later on if you want. But this is a very good architecture if you don't want to miss out on failed records, right? So this is how a simple architecture can be by using Amazon API Gateway, Kinesis data streams, Lambda, and SQS. You are free to explore more and more, but the questions are going to be revolving around these services like this only. And just that the scenario would be different. They may add more words to the question, but how a particular service behaves in a particular architecture still stays the same, right? It still stays the same. Okay, so let us talk about the second architecture in this section, guys, and it's a pretty simple architecture of a lot of people use it. It's a very common architecture. It's a microservice based architecture, right? So what we have here is we have a client or a user. Obviously that user will call an API, right, and it will be handled by our API gateway, right? Pretty simple. Now if you know about API gateway, you can define rules in API gateway, right? And based on the rules, it will direct your request to a particular place. For example, we have a product microservice, we have a basket microservice, and we have a ordering microservice, right? Now, for example, for the product microservice, it will redirect to this particular Lambda function, which will have the business logic to handle whatever the logic related to product. It will have its own database, right? And then basket, for example, this is a cart microservice, you can say. I mean, if you add something to the cart, that logic might be inside this basket microservice. You are free to imagine what logic you want to put it here. I don't know if you want to keep a banana logic or a milkshake logic. I don't care about that. It's just you need to understand the architecture. These are bad jokes, but whatever. Then ordering microservice. Finally, after adding the product to the cart, you want to order something. So basically you have an ordering microservice. Now the point in here is that these microservices in turn will activate something, right? And this can be a checkout event. That activation can be a checkout event. Why? Because you select the product, you add it to the cart, and then you order the product, and it will be a checkout event, for example. And this event will be received by a AWS EventBridge bus. And it is a very common thing nowadays to use a EventBridge bus, because using EventBridge, you can have EventBridge rules, which can in turn trigger multiple AWS services. There might be another Lambda function, there might be another S3 bucket, there might be another SQS queue. Now the EventBridge has the power to trigger a lot of my services based on the event received. Now these events can further be buffered inside a SQS queue, right? Because maybe there are a lot of events coming in at once, and maybe this there is some events which are going to be missed. You are I don't know, thinking that in the future maybe the load will increase and maybe we are going to miss on certain events. So what you do, you just place a SQS queue in between, right? It will act as a buffer, right? Whenever in the exam you talk about decoupling, this is a basic architecture or decoupling architecture. You are decoupling a lot of things in this architecture, right? Whenever in the question it comes about decoupling of architecture, creating a buffer between the architecture, or retry mechanism, right? Retry mechanism, right? Failure and retry mechanism, or fan out pattern, all these things, all these terms that you hear in these architectures are basically based on SQS, SNS and all these things, right? So this is how it works, guys. Now you can add multiple more things. Now this all, whatever this architecture, can be a part of a CloudFormation stack, right? So that manually you don't have to, for example, this is in US East 1A and you want to replicate the same architecture into another region, for example. Or the best way is that this is a dev environment and you want to replicate to a prod environment. You tested in the dev environment, this architecture works best. You did all the stress tests and everything. Now you want to replicate it to a prod environment, right? It's better to keep a CloudFormation stack so that you don't miss out on the configurations, because CloudFormation literally means infrastructure as code, right? So that's it. You can add multiple services, whatever you feel that is required in this particular project, you can add it and it can be a part of the architecture. But keep in mind, guys, don't do the over thing, right? Sometimes we feel that we have the knowledge and we can add multiple things which are not required, and it will eventually increase your cost, right? So keep in mind and you should be good. All right, guys, so let's move on to the next section of architectures that we're going to learn. Okay, guys, so let us talk about this architecture where we see API with some security principles, and obviously we're going to use some security based services from AWS, right? And how you can integrate it with your application, and yeah, in which sections of your architecture these things come into the picture. So very interesting thing, right? But before diving into this particular architecture, I want to revise some of the services, because I suppose I have not covered these services as part of my video series. But if you want a detailed security services video on AWS, please let me know. I can make another video on that. But just for the context of this particular architecture diagram, we're going to talk about a little bit about, first of all, is WAF or web application firewall, right? So that helps protect web application from APIs from attacks, right? But which kind of attacks? So you can configure rules, and you can which is known as a web ACL, which is access control lists, right? That can allow, block or count web requests based on customizable web security rules and condition that you define. Now where do these particular this WAF comes into the picture is that it basically provides protection against web exploits, right? Like SQL injection attacks and cross-site scripting attacks. It's more helpful in this scenario where there is an active intruder which is trying to do some kind of coarse thing, or some cross-site scripting attacks, or some OWASP attacks, right? If that is the scenario, then basically this thing you should use it actually. And basically this WAF is used on the either on the CloudFront level, or your API gateway level, or your load balancer level, right? So let's take an example. You can create rules to allow or block requests from specific IP address ranges, requests from CIDR blocks, requests that originate from specific country or region, requests that contain malicious SQL code, or requests that contain malicious script, right? So that is the thing. That is about AWS WAF or Web Application Firewall. The second thing that I want to talk about is the AWS Certificate Manager or ACM. So it's a very simple thing. It's used to store, manage and deploy your TLS certificates, right? Whatever certificates you have. For example, you have a server and you have a client, and the server wants to connect to the client, or I mean it's the other way around, the client wants to connect to the server. This will have its certificate. The server should have the client certificate, because there will be a two-way handshake between the server and the client, right? So the same certificate should also be there as part of the server, right? It should be a client certificate. So for this to happen, if your infrastructure is built on AWS, you need ACM, which is a certificate manager, to easily deploy your TLS certificates, and it just cuts down all the time consuming process of purchasing, uploading and renewing SSL TLS certificates. There is also one facility where you can also renew your TLS certificates automatically using ACM, right? So yeah, these two things, I think these two things are the important things that you need to know about the architecture. Other things I've already discussed in my videos, and it's pretty general, so I don't think I need to cover those things. Okay, now let us talk about this very I would say efficient architecture, because it's a very good architecture actually. I like it very much. Now let us talk about this thing. So the first thing is the user, right? Whenever the user calls an API or just sends a request, it hits the CloudFront, right? And in my video, in my CloudFront video, I've told you that CloudFront is a CDN, or a content delivery network, right? It's used to distribute content across the whole world, right? You have your edge locations, right? And you have your source. So it will be much faster to transfer the content over the CDN. So that's a very good choice to put the CDN at first, I mean the CloudFront, right? So whenever, for example, some guy or some person makes a request, for example, I don't know, www.example.com, something like that, /users or something like that, this API, right? It will be routed to the ALB through the CloudFront. Now, if you remember my CloudFront video, CloudFront is not only used just for static content, it can also be used for dynamic content as well. So it can have what we call multiple sources, right? It can have a static S3 as a source, or it can have an HTTP endpoint as a source, or it can also have an application load balancer as a source. There is no limitation that CloudFront can only be used as a static thing, right? So using Route 53, right? It is a DNS service of AWS, DNS service of Route 53. It redirects it to your application load balancer, right? Now, when the request comes to ALB, so what will happen? There is a WAF rule associated with your ALB, right? And it will filter out the request based on your ACLs that you have written, your access control list, whatever rules you have written, it will filter out the request. If that seems to be a malicious request, it will not accept it, right? And another thing that is associated with it is the ACM or whatever, right? Now, what ALB will do? ALB will do termination or TLS termination, right? Obviously, it will look for your client certificate or other set of certificates that you have, or a certificate bundle, whatever, how you have configured it. It's up to you. It will look it for that certificate in your ACM, and then it will terminate the connection. TLS termination will happen, and then what will happen? It will, it will send it to your VPC endpoint, right? Which is this part. Now, you can ask a question, why do we need a VPC endpoint, right? Now, if you remember, I have talked about the VPC endpoint, that if you want something to access in your private network, right? For example, this private API is there, right? If you want to access that, you cannot access that over the public internet, right? It is not possible. It has a private IP address and it's not possible. So if you want, this is also an API gateway, right? This is the API gateway, this is the API gateway, and this is the API gateway. Now, if you want to access one of the API gateways of domain 1 or domain 2 and domain 3, now you need a VPC endpoint for that. Simple as that. Now, for example, example.com, if it is /domain1, right, it will redirect to this private API. If it is slash domain 2, then it will redirect to this API. If it is slash domain 3, then it will be this particular private API. Simple as that. So www.example.com, if slash domain 1, right, it will redirect to this thing, and all these routes are configured in your route 53. So just try to interconnect all of these things, and then what will happen in if it reaches this private API, this will obviously it will be triggered, Lambda function will be triggered, which is a service, right? So every private API has its own service which will contain its business logic, and this in turn can connect to a separate AWS service. We are not going to worry about that. I hope that is clear, right? If you have any questions, please put down in the chats. Now, what are the advantages of this kind of architecture? That also we need to know, because some questions may also come, like what are the advantages of this, and they will give you some options on that, or this also can be a interview question. First of all, the security. So this API approach improves the security of the application by reducing the attack surface, right? Because you are using WAF in this, and very, very important, if you want to strengthen your security a little bit more, you can use AWS Shield with WAF. There is also another other architectures with this combination as well. You can also search for it, and if obviously I'm going to make another architecture video. If I feel like this is important, I'll include that as well. But even though you with WAF also you get a very good this thing like prevention of attacks. Second thing is you will get a very good operational thing, right? Why? Because each team can independently deploy their application. Each is a separate microservice, because if you see, there are 3 private APIs over here, each associated with its own microservice. So this is a very good thing, right? It makes sense. Next, performance is very, very good, and I just noticed, I also told this from the start, that in this particular architecture, performance is like off the bat, it is amazing, right? Because you see, CloudFront increases the performance. The first thing that you should come into mind when you look at this architecture performance wise is that because there is CloudFront, its performance should be good. Next thing is cost, right? The ELB is used as a single entry point and brings an extra cost, as if you have multiple public API gateways, then it will be more costly, you can say. But here there is a single entry point, and then you have your gateways or whatever that is in the backend, right? It makes sense. Okay, so I think this is it about this architecture. I hope this is making sense, right? If you have any questions regarding this, please put it down in the chats, and I'm going to look at that. Okay, for this video, the last set of architectures that we're going to see is the design patterns or events design pattern, right? And basically the questions revolve around these things only. So first thing, very simple design pattern, right? Synchronous and reliable point-to-point processing thing. So you have your S3 bucket, right? You have your S3 bucket, and you can have a S3 event notification, and synchronously for every event you will invoke your Lambda function, and this Lambda function will do something like it will run an Amazon recognition job or something like that, right? It's a very simple thing. So it's a synchronous thing. So whenever an event occurs, you just invoke the Lambda function, trigger the Lambda function using S3 event notification. Simple as that. Second thing is asynchronous and queued point-to-point processing. Is just the extension of the first one, but instead of being a synchronous execution flow, this will be an asynchronous execution flow, where you have a S3 bucket, for example. This S3 bucket will trigger an SQS queue, an S3 event notification, and also trigger that. And this SQS queue will act as a buffer between your S3 bucket and your Lambda function, right? And then the Lambda function can trigger something else like an Amazon recognition job. This is nothing but a decoupling, right? And I'm using these terms over and over again so that it will stick to your mind, and whenever this kind of stuff comes in, it will be amazing. All right, this is pretty simple. Let's move on to the next thing, parallel processing. Now whatever we are seeing over here, this is a single flow, right? This is, even though this is synchronous, this is a single flow, and this is also a single flow, but there are certain points of time when you need parallel processing as well, and this is an example of that. And this is the classic fan out architecture, right? I'm not talking about taking a fan and getting some air. It's a bad joke, but whatever. It's a fan out architecture. I don't know why am I getting these lame jokes in my mind. I'm not going to give you any other jokes. Let's focus on this topic as of now. Fan. Okay, whatever. So we have this S3 bucket over here. This will I don't know, based on some event, it will send it to a topic in SNS. And then this SQS queues, this one and this one and this one, these SQS queues can be subscribers to this SNS topic. So whenever SNS publishes some message into the topic, these will be alerted and message will be pushed into their queues, right? Simple as that. Now for each SQS queue there is one Lambda function which is doing some job, right? So there is a single source and it is just fanned out. That's a very good fanned out. The events are fanned out to multiple SQS queues using SNS over here. It's pretty simple, and we have discussed this in detail in my last video, or last video, which was SQS and SNS, right? Okay, it makes sense. Now let us talk about the last one. It's just that we are adding a layer on the top. So you have the base, you just make it so like you have the foundation of your house and you keep building on your house, right? Similarly, we have our base, right? We started with a single flow. You just add more elements and it will be like you are evolving your architecture, right? So here what we have is we have one SNS over here which is for new images. For example, you upload a new image and this particular SNS topic will be triggered, and then you have another SNS topic for deleted messages which will have its another flow. You can just name this as flow number 1, this you can name this as flow number 2. So for new images, flow number 1 will be triggered, which in turn will be, there will be 3 subscribers, 3 SQS queues as subscribers to the flow number 1 or topic number 1, which will have its own Lambda functions over here. So this this Lambda function is polling from this queue, this is polling from this queue, and this is polling from this queue, and then the Lambda function is doing something with the other service like recognition or S3 or something like that. Then from flow number 2, for example, you delete some message, then some other flow will be triggered over here. This topic, for this topic there is only one subscriber over here, which is your SQS queue, right? And then we have Lambda function, and then we have this Lambda function is again associated with a target S3 bucket, right? Hope that makes sense. Pretty simple. So all these things are fan out architecture, guys. Whenever you talk about fan out architecture, it is just the combination of SNS plus SQS. I have talked about it so much that you will start saying fan out in your daily lives also. Don't use it too much. Sometimes it sounds a little bit weird also. So yeah, it's up to you. Okay, just don't go to your friend and say this, use the fan out architecture in your real life, and also fan out your relationships. That's a very bad joke actually. Don't take it by heart. Okay, whatever. So the last thing that we want to see is real-time notifications, right? And you have your S3 bucket over here. Then it is publishing something to the SNS topic. This SNS topic is has a subscriber and SQS queue. Then this Lambda function is polling from the SQS queue, and then there is another SNS topic over here, which is basically, this topic is basically for sending the push messages, for example, and it has one mobile subscriber over here. So whenever a message is published to this topic, it will a push notification will be published to the mobile phone, right? Pretty simple as that. And then we also have this Lambda function, which is also polling from this SQS queue, and basically it is doing something to a target S3 bucket, right? So this Lambda function is triggering two things over here. It's doing something, I mean publishing a message to the SNS topic, and also doing something to a S3 bucket, maybe uploading an image or deleting an image or manipulating an image, creating a thumbnail, whatever business logic is there in this Lambda function. We don't care about that. We are just going to be cared about the real-time notification. For example, you can just make it like uploading an image, right? A user uploads an image, or some post is uploaded by a particular social media user. So this Lambda function will first upload the image and then notify the users or its followers, right? It's pretty simple. You can just think of any kind of architecture. This thing is generic. Okay guys, so that was all about this video, right? And I'm going to make a second part to this video. I don't want to clam all the architectures at one place in one video, so I'm going to make at least 1 or 2 videos more in this series. I hope you guys like it. If you have any questions, please write it down in the chats. So till then, have a nice day, take care, and bye bye.